Welcome to this explainer. So today we're breaking down a massive shift in how we handle HTTP communication in modern Angular. If you've been working with Angular 15, 16, and beyond, you already know standalone components are completely changing the game. But, it's not just components getting a facelift. We're going to focus on how to modernize your HTTP communication using functional interceptors. We'll look at the syntax, chaining, and how to wire the whole shebang up perfectly with the latest standalone APIs. Let's get into it. Now think about this. How do you add auth, caching, and logging to every single HTTP request without writing identical code over and over? This highlights a very real-world developer pain point. Imagine an app making dozens or even hundreds of different requests. You need to attach an auth token to almost all of them, right? You need to log errors for all of them. Are you going to manually add that logic into every single service method? Absolutely not. That's a maintenance nightmare. And that introduces interceptors as the ultimate solution, a way to handle these cross-cutting concerns globally and cleanly. Section 1. The power of interceptors. Middleware for your HTTP requests. To really get this, think of an interceptor like a highly specialized worker on an assembly line. Every time your app makes an HTTP request, that request travels down the conveyor belt. The interceptor catches it, inspects it, maybe modifies it like slapping on a custom header, and then safely passes it down to the next step. It's essentially acting as middleware. And the beauty of it? It can also catch the response coming back from the server before your application even knows it's there. This brilliantly illustrates the direct contrast between the old way and the new way. In the pre-Angular 15 world, creating an interceptor meant rating a really bulky class. You had to implement the HTTP interceptor interface, set up a constructor for dependency injection, and write a ton of boilerplate, literally just to get a simple console log. But now, we use functional interceptors. It's just a simple function with zero boilerplate. It's sleek, it's lightweight, and it completely embraces Angular's modern functional direction. Section 2. Functional syntax and inject. Equipping your assembly line workers. So let's look at the actual syntax of these new functional workers. The basic setup is incredibly straightforward. You define your interceptor as an HTTP interceptor FN. It just takes two parameters, the outgoing HTTP request, usually just called rec, and a next function. That next function is absolutely critical, by the way. It represents the HTTP handler FN, which is essentially the next step in the processing chain. So your function does its work, calls nextRec, and returns the result as an observable stream. Simple, right? Now, what's really interesting here is a major gotcha that catches a lot of developers off guard. Because we threw away the class structure, we obviously no longer have constructors to inject our services, like an auth service or a router. Instead, we rely on Angular's new inject function. But listen, inject function has very strict scoping rules. It must be called from within an injection context. If you use it in the wrong place, Angular's going to throw a massive error that has literally ruined many developer afternoons. So how do we actually solve this? Well, to avoid that dreaded injection context error, you must safely call injecting outside of the RxJS return pipeline. You do this right at the top level of your interceptor function before you return anything. You grab your auth service or your router right up top. Then, inside your RxJS operators, like catch error or tap, where you're actually processing the request or response, you just reference that injected variable. Keep your injections at the top and your assembly line will run flawlessly. Section 3. Registering your interceptors. Putting the workers on the line. All right, now that our functional interceptors are built and properly using dependency injection, we need to actually wire them up to the assembly line using Angular's standalone API configuration. Standalone components are all about reducing boilerplate, and the HTTP client is no exception. We no longer import HTTP client module. Instead, in your app.config.ts file, you use the provide HTTPC function. To register our interceptors, we simply pass the with interceptors function directly into provide HTTP. Inside with interceptors, you just drop in an array of your functional interceptor names. Honestly, it's that clean and simple. But let's pause here for a crucial architectural tip. If you're lazy loading routes, you gotta remember that those routes create their own inner environment injectors. If a lazy loaded route defines its own interceptors, Angular by default might completely ignore the interceptors you set up at the root level, meaning your auth tokens could suddenly disappear on lazy loaded pages. No way we want that. To fix this pitfall, you need to use the with request made via parent function. This basically tells Angular to pass the request up the chain, ensuring your root level interceptors, like your global auth or logging, still fire correctly even inside those lazy loaded modules. Section 4. Chaining and execution order, the sequence of the assembly line. Let's follow the journey of an HTTP request. When your component fires off the request, it doesn't just go straight to the server. It sequentially passes through each interceptor worker on the line. In this example, it hits the auth interceptor first, which might attach a token. Then, the modified request is passed to the logging interceptor, which logs the destination URL. Only after passing through that entire chain does it finally head out to the backend server. So the absolutely crucial point derived directly from our sources is this. Angular executes your interceptors in the exact order you list them inside that with interceptors array in your config file. Order matters immensely here. If your logging interceptor runs before your auth interceptor, well, it won't be able to log the authentication token because it literally hasn't been attached yet. You are the architect of this assembly line, so make sure you sequence your array carefully. But remember, the assembly line runs both ways. When the response returns from the server, it travels back through that exact same chain, but in reverse order. So the last interceptor to touch the outgoing request is the first to touch the incoming response. Our logging interceptor sees the response first, passes it to the auth interceptor, and then it finally arrives back at your Angular component. This reverse pipeline is absolutely perfect for things like globally catching and formatting server errors before the component ever even sees them. Section 5. Practical Interceptor Use Cases. Real-world assembly line setups. Knowing the syntax is one thing, but knowing when to use them is where the real power lies. These are the most common patterns where interceptors truly shine. Instead of hard-coding logic into every single service, you use interceptors to abstract complex operations. You can automatically retry a failed request using an RxJS operator inside an interceptor. You can cache responses to prevent duplicate network calls. You can even toggle a global UI loading spinner state right as a request leaves and hide it when the response comes back. It's incredibly powerful. Here's a practical cheat sheet mapping those real-world use cases to specific Angular interceptor capabilities. For authentication, we modify headers. For logging, we simply read the request URL. And for error handling, we can tap into the catch error RxJS operator to handle network drops or 500-level server errors gracefully, maybe showing a global snack bar alert so the user isn't just left in the dark wondering what went wrong. Now, as you look at applying these use cases, it's highly, highly important to remember a core rule of Angular HTTP. Request objects are strictly immutable. You cannot just change a property on the request as it passes by. Any modification you want to make, like adding that auth token to the headers, requires you to clone the request first using the rec.clone method. Apply your changes to the clone and then pass that clone along to the next function. Finally, what if you have a global rule but you need an exception? Say you have a global loading spinner interceptor, but you have one specific background pulling request that definitely shouldn't trigger the UI to spin. You can bypass logic by using an HTTP context token. This allows you to attach custom metadata right to the request when you make it in your component. Your interceptor can then read that token, realize it says skip loader, and simply pass the request along without triggering the spinner. It gives you incredible granular control over your global middleware. Functional interceptors prove exactly how much cleaner and more maintainable our code can be when we shed unnecessary boilerplate. By utilizing HTTP Interceptor FN and configuring them elegantly with Provide HTTP Client, we've modernized the entire HTTP pipeline. But it leaves us with an exciting, provocative question. As Angular fully commits to the standalone functional paradigm, what other bulky, class-based features are next on the chopping block to be streamlined into simple, powerful functions? Think about that as you update your code bases. Thanks for watching this explainer, and we'll catch you in the next one.